Hi guys, let's continue our journey into the land of quadratic expressions in this session by having a look at factorising expressions with three terms. Factorising meaning putting the brackets in, whereas in the last session we did expanding, which is taking the brackets out. So factorising expressions with three terms, that is quadratic expressions with three terms, it's called a trinomial. Tri meaning three, nomial meaning number or term or whatever you like, but tri meaning three. Yes, quadratic trinomials can be written in the form ax squared plus bx plus c, where the highest power is a squared term in x. That's what makes it a quadratic, guys. That's its signature of quadraticism. Alright, so let's go. Factorising ax squared plus bx plus c when a equals 1 first up, and then we'll deal with same thing when a is not equal to 1 later on. Same techniques are used basically, but when a is not 1, it just makes it a little bit more challenging, perhaps a little bit more complicated. But look, we'll do the a equals 1 first, show you how to do it, and then when you feel comfortable with that, you can launch into the land of the a doesn't equal 1 situation. Okay, as I said to you, factorising is the reverse of expanding. In factorising, we put the brackets in. So, as you will have found out in the last session if you've had a chance to watch it, this with the brackets expands to that, which becomes that. No brackets inside over here. So it also follows then, guys, that if you were to go in the reverse process, that this would factorise to this. Of course it wouldn't. I'm going to show you how to do it. How do we factorise? Well, you have a choice of two methods, okay? This one here, factors and group method, which we'll call method A, and you've got the cross product method, which we can call method B. And I'm going to show you each of them in detail, okay? Alright, here comes method A, factors and group. This is the one I prefer. Y equals ax squared plus bx plus c. Now step 1, there's a few steps here, and it might get a bit confusing, but I'll show you by way of example, okay? Step 1, you find a times c. In step 2, you then find factors of a times c, which either add or subtract to give b. Confused? No. Just hang in there and I'll show you. Okay, step 3. We rewrite the quadratic now that we've found what we were looking for in step 1 and 2. We rewrite the quadratic as a 4-term expression with the x term up here replaced by 2 terms, using the factors that we found in step 2 as the coefficients of these two x terms. Now, that doesn't sound very easy to understand as it is, but look, just hang in there, I'll show you, right? Step 4, we factorise by grouping 2 by 2, and then we take out common factors in each group, and then that gets us the final result when we then factorise that one more time. Yes, don't turn me off. Here it comes, the example to show you, okay? This is the blueprint. This is the practical application of it. We're going to do both of these, okay? Now, here we go. Alright, now I've rewritten this thing, x squared minus x minus 20, the objective being to factorise this, right? Okay? Right, now that's 1 x squared, so the a term is 1, right? Minus 1x, right, so the b term is minus 1, minus 20, which is the c term there. Do you get what I mean? So I'll just show you that. Now you see a is 1, b is minus 1, and c is minus 20, right? Now the first thing we've got to do is find a times c, all right? So a times c, can you see that, is minus 20, yes? Now what we've got to do is, I'll show you. Factors of minus 20 are, well, 5 and 4. 5 times 4 is 20, isn't it, right? Now, you see from this middle term, this b term here, the b term is minus 1. And you can see that minus 5 plus 4 gets us to minus 1. So that's what I'm talking about over here in step 2, where we find factors of a times c, which either add or subtract to get b. See, now it's all becoming clear now. isn't it? Yes, yes it is. It's becoming clear. Right, now, so that is the answer to what we want here. So now we're going to use those two factors, the minus 5 and the plus 4, to rewrite the expression. That's b. Yes, it is. We're going to rewrite the expression like this. X squared minus 5x plus 4x. So instead of, where is it? Instead of this minus x, we're replacing that with the minus 5x plus 4x. Okay, that's what you're doing in step 3 here, rewriting the quadratic as a 4-term expression with the x term replaced by 2 terms, aka this one and this one, which we found in step 2. And these factors here, the minus 5 and the plus 4, are the coefficients of these x terms. Alright, you get that? Now, watch what happens now. We're going to group them, guys. We're going to group them 2 by 2, okay? Now, we're going to take out common factors as follows. See, look, x into x minus 5. That's what that is if you take out the common factor, which is x in both cases. And this one's got a common factor of 4. See? That's what you get. Now, the plot thickens now. I've grouped the thing 2 by 2. That was step 4. Right, and I've taken out the common factors. That was step 4. Now, step 5 is we're going to factorise that again by taking out this common factor, okay? If you take x minus 5 out of this, you're just left with this little beastie, the x. If you take x minus 5 out of this one, you're just left with the 4. So you can rewrite that as, look, x minus 5 into x and 4. You see? That's how you do it. And that is the final factorised result. Thank you, Mr. Box. Very, very exciting. Okay, now we better do another one while we're hot on the trail here. Number B. For you and me and Yippee, it fills us with glee and all the rest of it. Now, here it comes. Now, the very, very first thing that you should do, ladies and gentlemen, is don't launch straight into it. Always look for the common factor. There is a common factor in this, right? These are all even. The minus 2 is even, the 16 is even, and the minus 14 is even. So that means we can take out 2, or in fact we could even take out minus 2 if we wanted to, which I did. Now, you've got to make sure that this is right. And to make sure it's right, you would need to, on a spare piece of paper somewhere where you can jot and just do some rough working, you'd be well advised to re-multiply that out again to make sure it comes out right. Let's just do it, you and me together here just now. Minus 2x squared, check, okay, check-a-rooney. Minus 2 times minus 8x gets plus 16x, because 2 minuses make a plus. You know that, don't you? And then minus times a plus gets minus up there, and 2 times 7 gets 14. Yes, everything's looking mighty good, okay? Now what we're going to do, guys and gals, is we're going to factorise this thing in here, using our marvellous new patented factors and group method, right? So, let's go with that. Yes, I've rewritten that out for you in that form where you can see this is the A term, this is the B term, and this is the C term. Yes, if it's ax squared plus bx plus c, like up here. Alright? How you going? Yes? Good? Okay, well come on, let's keep going then. This is now 1 times 7. A times C is 7 now. And you know very well, guys, that using those factors, minus 7 minus 1 gets us minus 8, and we've hit the jackpot again. You see? We've just added those two minus 7 and minus 1 terms in the minus form to get minus 8. So now we're going to rewrite that thing. What we've got is minus 2 times. Now we're replacing that middle term, that minus 8x, with minus 7x minus 1x. Okay? And then we're going to do the old group trick. Yes? You see whether you can figure out what the common factors are while I get ready to show it to you. Aha! Alright, so x was the common factor in here. And now this is a bit tricky. Look, minus 1. If you take minus 1 out of that, it changes the sign of what's inside the brackets. That's what it does. So that means you get an x there and you get a minus 7 there. Okay? Now, look, see, I've got this x minus 7 here. I've got x minus 7 there. So that is now in common to both of those terms inside this bracketed thingo here. Okay? So basically you can take x minus 7 out of both of those terms and you see if you can think what I'm going to get on the next line. You ready? Here it comes. Abracadabra. Ooh-hoo. Look at that. That's minus 2 times. Now, here's your x minus 7. Now, if you take the x minus 7, even if you just blot it out with your finger on the page or something to see what's left, there's an x left there. If I take it out of here, I'm left with a minus 1. So there's where you get your x from up there and your minus 1 from over there. So there's your answer. Look, minus 2 times x minus 1 times x minus 7. And there she be, guys. There it is. It's beautiful, isn't it? It is. Now, what's next on the agenda? How can we top that? Well, we're going to use the cross product method now. This is the other method which I promised to show you for factorising quadratic trinomials. Now, let's do the same two that we just did before using this cross product method, okay? This is a bit of a trial and error thing. In order to get the right factors, you sort of got to try and, try various things until you get what works. Now, what you do here, guys, this is a different technique. So what you do is you take the front terms. The front term here is x squared, right? And you write down here, okay, that'd be x times x gets me x squared. So this is going to be the first term in the first bracket. This is going to be the first term in the second bracket. Okay? So that's that one done, right? Now we'll do the rear term. Now, this is the minus 20. Okay? So I'm saying that minus 5 times plus 4 gets me, multiplies together to get me, minus 20. Okay? That takes care of that. So I've got the front term done here. I've got the back term, the rear term done here. Now, we've got to make sure now that this middle term works out being correct. And how we do that, yes, that's correct, that bit. Now, how we do that is we do diagonal multiplication. And the result of the diagonal multiplication this way, of the plus 4 and the x, and of the minus 5 and the x diagonally this way, has to come out to minus x. Otherwise, we've got it wrong. Okay? Now you can see that minus 5 times x plus 4 times x gets us minus x, which is correct. Bonanza. There it is. So we've done it. We've got it, guys. Now, the answer after you've finished doing all that, this is the first term in the brackets, x minus 5. This is the second term in the brackets, x plus 4. Yes, and that's how you do it. So, you multiply vertically. That's this times this gets me this, to get the first term and the last term of the expanded version, right? X times x gets x squared, minus 5 times plus 4 gets minus 20, yes. And then what you do in the second stage of it, you multiply diagonally to get the middle or x term. And then you can, if that doesn't work, if you haven't quite got it right, then you continue using trial and error until a successful solution is found. E.g., like for 20, I could have done 10 and 2 or 20 and 1. And I would have found out that if I had done that, that this cross diagonal multiplication thing would have yielded the wrong x term over here. So you'd have to then sort of have another go and try again with different factors. That's what you do with this method, okay? So there it is. Now, what's 4? Yes, so therefore we've found that the factors of x squared minus x minus 20 are therefore the first term, that one, x minus 5, and the second term, that one, x plus 4, multiplied together in their brackets. Okay? there it is. That's what you do. All right, we better have a go at number B now. Okay, the first thing you do is take out the common factor. That's very important, okay? Minus 2, I took out minus 2 so that I could get a nice positive x squared term in here and all the rest of it. It's just easier to factorise if you have a plus coefficient, plus 1 coefficient in front of the x squared term here. Now, so we've got to do the cross product method on this thing here, guys. So let's go with that. Oh, goody, look at that. So x times x gets x squared. That's the front term in each bracket. First bracket front term, second bracket front term gets us x squared. X times x is x squared. This is the rear term. So we've got minus 7 times minus 1 gets us plus 7, and that was a plus 7, so everything's good so far. But here comes the acid test. Does the diagonal cross multiplication yield the right middle x term? Let's see. Minus 7x minus 1x gets us minus 8x, and goodness, it's correct. So we're laughing. We've done it. Okay? There it goes. So that's the answer to that one. Are you pleased? Do you like the idea of it? Which one do you like better? Do you like the factors and grouping method, or do you like this cross product method? It's your choice, really. Now, this is part B of this video. We're going to factorise quadratic trinomials when a is not equal to 1. As I said to you, it is the same procedure that we use as when a was equal to 1, but it's just a little bit more challenging. It may take longer to find the solution as it can be more challenging. I'll show you. The coefficient of this x squared term here is not 1, it's 10. 10 for goodness sake. Now we'll do a grouping method and we'll use the cross product method and we'll see how we go, guys. Part A, grouping. Alright, now let's go with it. Now, okay, this is the A, this is the C, the minus 2, right? ax squared plus bx plus c. Okay, so a times c gets minus 20, doesn't it? Now we've got to look for factors of 20 which can get us minus 1, because the b term is minus 1. Okay, well, there they are, guys. There they are. Yes, very satisfying. So therefore we can say that minus 5x plus 4x gets minus x, and there's the thing there. That's the term. So we're right. So we rewrite it as a 4-term quadratic like this, like that, yes, and now we do the old group trick, yes? Okay, so that's common factor. For the first two terms is 5x into 2x minus 1, and then plus 2 into 2x minus 1. And again, you can see that now this term here, this bracketed term, is in common to both, so we take that out as a common factor, we get left with that. That is the answer. Thank you, Mr. Box. Yes? So, same procedure as I said. Now let's do the cross product method now on that particular same example, okay? So we're saying, okay, the 5x times the 2x gets us 10x squared. Yes, that's for the front term in each bracket. We're expecting a 5x as the first term in the first bracket and a 2x as the first term in the second bracket will get us that. Let's try the rear term now. It's got to add up, it's got to multiply together, to give minus 2. So we're trying minus 2 and plus 1. Now, here we go. We've got to try the cross diagonal multiplication here to see if what we get comes out to be minus x. We'll see how we go. That one's right. Now, what do we got here? We've got 5x minus 4x gets us, oh dear, it's got to be minus x. Oh, we'll have to start again. We've mucked it up, guys. What a shame. It's not correct. Let's go again. What about if we reverse the signs of these terms over here? Plus 2 and minus 1 instead of minus 2 and plus 1, and hopefully that'll get us a better outcome. So that's still 10x squared. That's still minus 2, so everything's okay so far. Now let's do the diagonal bit. Yes, that's good. So we get minus 5x plus 4x. Oh, good. That gets us minus x, which is what we were after. Yes? So therefore that's correct, and we know that our answer is this term times this term. Yes, everything's absolutely wonderful, and we know how to do it, and you can have some fun now. That's the end of the show. I don't propose to go through all those points there in the remember box, but if you'd like to pause the video and just have a look at them, you'll see that they're fairly self-evident as you go through them, and they're good for you to go through just to reinforce the learning that you've gained in this session. Alright, I'm going to hive off and have a nice cup of tea now, and I'll see you soon in the next exciting instalment in the land of the quadratic expression. Bye for now.